Here we go, our lesson on 2.2 and subsets and Venn diagrams. Hopefully you've already taken some notes from 2.2. You should take notes every time you go through the Learn section. There's lots of good stuff in there. So before you start doing practice or certify, make sure that you go through the Learn mode, watch the videos, read the stuff, and take notes of stuff that feels important. And then when you get into the practice mode, kind of highlight the things that you ended up using, because those are the things that will end up going onto your sheet for when you take your exams. So we're going to go ahead in and do a problem. We're going to start with this problem, and a most common or the most helpful thing that you can do with a problem that's written in this like set builder notation up there is to write it out in roster notation. So this says y such that y is an integer greater than 40. Integers are negative and positive numbers, but we're greater than 40, so it doesn't even really matter. So A is the set. Okay, and we're going to do roster notation. So Chris is here. Chris, what should I write?
You should write 41, 42, 43, and end with dot, dot, dot.
43. That's enough to get the picture and end with dot, dot, dot. Okay, so that, because there's no way we're going to like keep writing because it doesn't end, right? So, okay, so we're going to do that. And that kind of almost lines up. I'm going to move it over so that it lines up with the thing above it. Because that shows us kind of what the relationship is. I'm going to move it up a little bit. The relationship here is that A being that, and B being, and I'm going to move it over because I like to be obnoxious like that. I'm going to move my mouse. B is 43, 44, 45, and 46. And that's it. So it shows us that B is a subset of A. So I would write it, do they have a universal set? The universal set is, okay, so the universal set, maybe, it doesn't matter that much, but the universal set is this funky Z, which is all the integers, which I think we talked about earlier and is definitely in your notes that you took from the last section. The funky Z is all integers. So from negative huge number through 0 all the way through positive huge number, or infinity, or however you want to say it. So the Z is all integers. So Z would be the universal set here, and B is smaller than the set A because set A is 41 through forever, whereas B is just these four numbers. So we would have A being here and B inside of A. So I like to, what's really hard with the online stuff is that you see your multiple choice answers before you do the work. So I like to just draw it out and ignore it. You guys probably don't have a way to cover things on your computer screen. You could open a Word document, but nobody's going to do that. So we'll go down here. So B is definitely a proper subset of A, which I don't know if that's relevant or not yet, but it's a proper subset of A. So we're going to look at these, and they drew it slightly differently than me, that I think we just click on it in this one. Boop. B is a subset of A, and then we say submit answer, which is off screen, and it says that we're right. So let's move on to another problem that students got stuck on. Okay, here's another commonly missed problem in the homework for this unit. And this one is about the difference between the number of subsets and proper subsets. And you should have this written in your notes somewhere that you took when you were doing the Learn mode. When you were in Learn mode, most likely you watched this video and read the definitions that were on the page before and scrolled down and you got to this set. And after you watched the video in Learn mode, you got down to this example that actually listed all of the proper subsets. If they had also included, change color pen, blue, this set here, then you would have had all of the subsets. But in proper subsets, you do not include the entire set, which is what they told you in their little video. So here's all of the proper subsets. In the example we're working, there's too many things to actually list them all out unless you have like a ton of time on your hands. So we're going to go over how to do that. The book is actually pretty nicely laid out, or the book, the Learn mode. where they give you another example that you can write it all out there and they'll display the answer once you practice it. So really spend time in learn mode and do this and take notes and practice. Don't just write down formulas, but actually do the practice it asks you to practice and check your answers. Then next, it tells you formulas. You probably like, oh, this is important. And that's what you wrote down in your notes is these formulas. Okay, getting back to the problem at hand, they tell us that N contains the traveler's choice top destinations for 2015 before we were in a pandemic and we could actually travel places. And so we have this list of elements because it's the roster notation for the set of travel destinations. And then we have these formulas down here. What do we need to do to make these formulas work, Chris?
We need to plug the cardinal number into N.
The cardinal number. Okay, so N stands for the cardinal number. And what does cardinal number mean again?
The number of elements.
The number of elements in the set. Okay, so we better count some stuff. So let's see. We've got 1 for Marrakesh. Why is it not writing? There we go. Marrakesh. I've never even heard of this place. Marrakesh makes me think of that song. But I've never heard of that place. Istanbul I've heard of. Hanoi is in Hawaii, right? Prague I've been to. London actually I haven't been to. Rome. I'm not counting. Oh my gosh. Buenos Aires and Paris, which I've also been to. So I probably should have put numbers here. I'm going to go back and put numbers in. All right, so I got distracted because I was thinking about places I've been. I should probably look up this place. And so we count them and there's 9, and a lot of people mess up when they count because maybe Paris seems like it's not part of it because it's not on the same place. So make sure you count the total number, like by touching your computer screen or whatever you need to do. Okay, and then it asks us how many proper subsets does this contain? So that means we need to use this formula here. All right, so proper subsets, that's all the sets except for the complete set. So we'll use that. So we do 2 to the 9th minus 1. And a lot of people have problems writing this on their cheat sheet where they put the -1 in the wrong place, but we're taking out the whole set when we count the number of proper subsets, because that's not a proper subset, that's just the set, which is a subset, but not a proper subset. Way too much talking. Let's stick this guy in our calculator. I don't happen to have my scientific calculator sitting around, but if you all have an iPhone, which a vast majority of the class does, you should be able to turn it sideways and it will give you a scientific calculator. So we need 2 to the 9 minus 1. So 2, and then to the power is this little guy right there, x to the y, if you see him, x to the y, 9. And then you get that answer, so it's 512, and you subtract 1, which I like to get one piece at a time, and I'll write that down in a second. And I don't know why I wrote subtract 1 on there, because we know what 512 minus 1 is. So I like to kind of just write things right below it. It was 512 minus 1, so there are 512 subsets, but then since we're doing proper subsets, we have 1 less, because we don't have the entire subset, so there are 511 proper subsets. Let's plug that in, make sure it says we're right. I'm getting rid of where I counted. So we've got 5, 11, and it's going to say yes. So, all right. All right, here's another one. A set has 32 subsets. How many elements are in that subset? So this is like a backwards problem. Sorry about that weird feedback. So this says that 32 is the number of subsets, and 32 is 2 to the n. And 2 to the n means 2 times 2 times 2 times 2, n times. So what I'm going to do is by hand, which is going to be a little bit nauseating for some of you, but that's okay, I'm doing it, and you'll be fine. And then we'll talk about other ways to do it as well. So 2 times 2 we know is 4. Times 2 we know is 8. Times 2 we know is 16. So let's do another one times 2, and that gives us a 32. And so now we need to go that we had 1, 2, 3, 4, 5 of those. So equals 2 to the 5. So I know that I didn't use calculators at all. Whoops. During schooling. but it was a long time ago, and you all are all like into calculators and stuff. So, Chris, what would you do to figure out that this was a 5?
I would just plug random numbers into n and see which one works.
Okay, so you would just like use your calculator and be like 2 to the 3, what does that get? 2 to the 10, what does that get? 2 to the whatever, like, and then just guess and check and go up and down.
Yeah.
Okay, that's totally valid and may have been faster than what I did, but either way is totally fine. So here, be really careful that you know what you're looking for here, because you're looking for the n, and the n is the cardinal number of the set or the number of elements in the set. So 2 to the 5 isn't your answer because 2 to the 5 was your 32. The 5 is actually the answer to this problem because you're looking for the number of elements in the set. And it's a little bit misleading because this box is huge. It's like, why is there such a huge box? Because all you're really putting in there is a 5. That's very weird to have this huge box and have that happen, but that's what you're supposed to do. And it said we were right. All right, last problem for the 2.2 video is a set builder notation with a bunch of stuff on it. So set builder notation is the one that last video we interpreted. In this video they're having us make it, but are we actually doing all of set builder notation, Chris, or what's going on with this problem in these huge boxes?
One thing to notice about this problem is it already has brackets and it already has the R.
It already has the brackets and it already has the R and that weird such that symbol. So there's really not that much else to add to this. The set builder notation is usually at x such that x is something. So they have the such that x, so all we need to do in here is the x, and it's spaced really funny. X such that x is an element of the real numbers, which it said. Okay, real numbers. And then here, the last part of set builder is, well, what part of the real numbers is it? And this says set of real numbers less than 5. So here we have to do x, and then we need our keypad. Oops, which isn't on screen. Let me scoot this over. All right, so I brought up the little keypad thing that you push here, and we need less than 5. So there's 1, 2, 3, 4 different things. Which one of these is the less than one?
The one on the top left.
Top left, less than, and it's not less than or equal to, it just says less than 5, so we're doing less than 5. And then we're going to submit our answer, because I think that's it. X is less than 5. I also wrote it down here because I felt like, and I forgot to close my bracket, which I didn't need to because they did it on there. But I wrote and on my paper when I did it. I wonder if and is going to be a problem. Let's see what happens. Submit. Okay, they didn't mind that I didn't write and in there. So this actually told me that it was right. So we're good. And I think that's all I want to do for the video today. Because those were the most commonly missed ones. And just, we're still kind of getting used to the system and like, why is this box so huge when we're just putting an X in it? I don't know. It just is. But so far, hopefully everything is going all right with the software. Next, of course, will be the 2.3 problems video. And then 2.4 is the one that gets pretty tricky. So I hope everybody's doing well. Post questions on the discussion board if you have them, and we'll talk to you soon. Thanks.